Okay, so for the notes, we're using inverses to solve. So I would maybe write it as the title, using inverses to solve. Okay, so if you guys remember, when we went over inverse functions, there was like a little packet of notes we did, and I talked about the difference between y equals square root of x when it was just written like that, and y equals plus or minus the square root of x. Do you guys remember the difference there? What does y equals the square root of x look like?
Oh, just like the thing that curves up.
Yeah, it's just the top part. So that is a function. This is an inverse function right here. This part right here was the result of having the equation. It was when we found the inverse, and we ended up having y squared equals x, and we had to solve for y. And whenever you're solving an equation using a square root, right, like you'd have to square root this to solve for the y. But whenever you're doing a math problem and you were the person that introduced the square root sign, you always have to put a plus minus in front of that. You guys remember that from just any time solving equations with square roots? So if we were to graph this, we would have to graph what Thomas just said is the top part, the positive square root x. But what about the negative square root x? What does that look like? Same on the bottom, yeah. And so this, while I can graph both of these, and mathematically speaking I can do both of these things, this doesn't pass the vertical line test anymore, so this is not considered a function. So it's an inverse operation because I can do it to solve for something, but it's no longer a function. So the important thing for you guys to remember when we're talking about inverse functions versus just using inverses to solve a problem is that an inverse function will look like it looked on your paper, where the inverse is in the problem. So if you see an inverse in the problem, automatically it's an inverse function. If you are doing a problem, hold on, the right one. If we are solving a problem like we have 2 sine theta minus 1 equals 0, we are going to have to introduce an inverse to solve this problem. So if you are the person introducing the inverse, then you're going to have lots of answers. Does that difference make sense? So if it says inverse on the paper, right, like this paper we just did, if the inverse is written on here, it is automatically an inverse function. If you're the one who introduces it, then you have to have all the answers involved. Yeah. It's for all, yeah, arc and inverse, those are the same. Arc cos is the same as cos inverse. Okay, so for example, we're going to do this problem and we're going to find all solutions, and the instructions on these problems are going to be really important because all of these problems actually have infinitely many solutions, which means the solutions can go on forever and ever, which you will see in a moment. So if I wanted to get theta by itself, what would I do first? I'd add 1. So I would have 2 sine theta equals 1. And then what would I do? So sine inverse equals 1, or sorry, sine theta equals 1 over 2. And then how would I get rid of sine? Sine inverse. So since we are the ones who introduced the sine inverse to solve the equation, then this is no longer an inverse function. We're using it as an inverse operation. So when we look on our unit circle, we don't just care about quadrant 1 and 4 this time. We actually care about all 4 quadrants. So where would the y-coordinate be? Positive 1/2. Pi 6 and 5 pi 6. Okay, pi 6 and 5 pi 6. So I'm going to write theta equals pi 6. I'm going to write theta equals 5 pi over 6. Now, if they told us to find 2 solutions that were on the unit circle, we would be done. But if you guys remember, we have something called coterminal angles. Can somebody remind me what a coterminal angle is?
It's like
Yeah, it's like greater than 360, or it could be a negative angle. So if I have pi 6, how do I get to one of its terminal angles?
Add 360.
You add a whole circle, right?
Yeah.
And then you add a whole circle to get another answer, and then you add there's infinitely many times you could do this, right? So we would be adding 2 pi to it. So the way that we write these answers is we write plus 2 pi k, and k is the traditional letter that is used there. I don't know why. But we think of this, we put k there because then we're saying k is just a multiple of 2 pi. So k could be negative 2. That could mean you're going backwards around the circle twice, you're getting a negative answer. So it just means you can go around the circle as many times as you want. So this is like half of our infinitely many solutions here. And then what should I put for the other answer? Also plus 2 pi k. Right? So that was on the other side of the circle. So if you add 2 pi over here, then we're going to have another answer over here and add 2 pi. It would keep going around. Okay? So the infinitely many solutions for this problem are right there. What's a good way to check your answer here? Yeah, plug it in. So if we typed 2 sine of pi 6 minus 1, we should get 0, and we did. And I should be able to type that in again with a 5 there, and I got 0 again. Okay? So we can, if this is on a calculator active, we can always check our answers. Okay? Alright, let's do another example. We're going to do 2 sine theta minus 1 equals 0, and we're going to find all solutions where theta is in between negative 2 pi and positive 2 pi. So this problem, this is exactly the same problem we just solved, but now instead of finding every single possible solution, we're finding some negative answers and some positive ones. Can anyone tell me how many answers for this problem we're about to have? We are going to have 2 between 0 and 2 pi, and then we're going to have 2 more between negative 2 pi and 0. We're about to have 4 answers. Okay, so I already know, based off the previous problem, I already know that I'm about to do sine inverse of 1/2. So I'm going to go ahead and just write that because I don't feel like solving all these steps again. But I know I'm going to get 4 answers this time. Am I going to put plus 2 pi k on any of those answers?
No.
No, because these do not go forever. Alright, so what answers could I write down first? Yeah, 5 pi over 6 and pi over 6. And what should I be typing into my calculator to find the other 2 answers? Yeah. So I'm going to take 5 over 6, and I'm going to minus 2 from that. So one answer is negative 7 pi over 6, and then I'm going to do 1/6 and subtract 2 from that as well. Okay? And what could I do if I was unsure of whether or not I got it right? Yep, plug it in. I could plug it in and see what worked. Okay. Are you guys ready for the next example? Yes, Ms. Rice, we're so excited. Okay, perfect. Perfect. Okay, here's the next example. Alright, we're going to do sine x plus square root 2 equals negative sine x. Whoa, chatty. Whoa, chatty. What should we do? You're explaining it? Live. Live. Okay, what should I do? Yeah, we're trying, it's the same as if you do a regular equation. You want all your variables together. Right now we've got x's over here and here. So what could we do to put them together? So you want to, it doesn't matter if you subtract it or add it. So we could do it like this. So we have root 2 equals, what is this right here? Yeah. Okay? And at this point, you don't even know how to find your answer because I didn't specify how many solutions we want. Let's go ahead and say that we want the solutions on the interval 0 to pi. So for these problems, it's super important to look at the directions to know how many answers you're trying to find. Yeah?
Add that negative to it. So that you feel like we're...
Because there's if you don't even think of the sign, if you think this is a negative x and another negative x.
Yeah. Okay.
Yeah, it's like there's two of them.
I thought that was like the same thing.
Yeah. Okay, so now to solve for x, what should we do? Yeah, divide by -2. So I have sine of x equals negative of root 2 over 2. And now what should I do? Sine inverse. Okay. Now, since we're saying we're taking only answers from 0 to 2 pi, can somebody tell me how many answers I should have? 2, yeah. We're going to have 2 on the unit circle. Okay, so let's look and see what are the 2 solutions. Wait, it's negative root 2 over 2?
Yes.
Negative 5 pi fourths is 1. Where else do we see a y coordinate?
Negative 5 fourths.
Now, this time, let's think this through. So we are used to, with inverse functions, having to say it is negative pi fourths, right? But if we look at this interval, is negative pi fourths allowed? No. So at this point, we're going to have to think of it this time as 7 pi fourths. It's the same spot as when you guys were doing inverse functions. We just have to make sure that our answer falls in the correct interval. Alright, so 7 pi fourths is the one we're actually going to use. So 5 pi fourths and 7 pi fourths. Sorry, there we go. Does this class get out at 9:30?
9:35.
35, okay. We're going to do one more example. I know, it's because my class is so exciting. Okay. One last example. We're going to do 3. Now on this one, just in case you guys have not seen this before, if you were to take tangent of x and square it, the shorthand way of writing that, because mathematicians always want to write things shorthand, and here the mathematicians are avoiding writing parentheses. So the way you shorthand this is you write tan squared x. So anytime you see this notation, it really just means that tangent of x is being multiplied by itself. We're just too lazy to write out the parentheses. So that's how that works. Okay. So this is really 3 times tangent x, and then minus 1. Okay, so what should I do? Add 1. So 3 tangent squared x equals 1. Divide it by 3. So tangent squared x equals 1/3. We're square rooting this. Now, anytime we square root to solve an equation, what should we do? Plus or minus. So we have tangent of x equals plus or minus the square root of 1/3. Whew. This is about to get ugly, yeah. So let's go ahead and fix that fraction. So this fraction right here, it's the square root of 1/3, which I'm going to write as the square root of 1 over the square root of 3. So I'm just splitting up the fraction and putting the square root on the top and the bottom. What is the square root of 1? 1. So right now we have 1 over square root 3. Are we allowed to leave it like that? No, what should we do? Yeah, root 3 over root 3. And so what is on the top? Root 3. What's on the bottom? 3. Okay. So what we are about to do is we have 2 equations to solve. We have tangent x equals root 3 over 3. and we have tangent of x equals negative root 3 over 3. And you guys, I keep doing this with these examples, I forget to tell you which solutions defined. I promise on the worksheet or in the book or wherever it already says how many defined. We're going to go ahead and find all solutions. We're going to find all solutions on this one. Yep, every single one. So we're going to have infinitely many answers. Okay, so what should I do right here? Tan inverse. Okay, so I'm going to tan inverse each side. Tan inverse. Tan inverse. So x equals tan inverse of root 3 over 3. And now this one's kind of tricky, right? Because tan does not show up on the unit circle in an obvious way. You kind of have to do some math with it. So what are you guys thinking? Which one gets you to root 3 over 3? Yeah, it's between one of these two, right? Yeah, and it's y divided by x would have to simplify. If you do root 3 over 2 over 1 over 2, that simplifies to just root 3. This one would be 1 over root 3, so this is the one we're talking about here. So pi 6 is one of the answers. And now the interesting thing about tan, do you guys remember what the period of tangent is? Pi. It's not a full circle, it's half a circle. So right over here is the other spot on the unit circle where we have pi 6. And this one we get 1/6 plus 1 pi gets us to 7 pi 6. And then how could we get some more answers? Keep adding pi, add pi, add pi, add pi, add pi. That's how we get the answers here. So when we write this out, we're actually only going to write 1 for this. We're going to say pi over 6 plus pi k. So sine and cosine have a period of 2 pi, so they get plus 2 pi k, because you have to add a whole circle to come back to that same answer. Tangent only has to add pi k, and you only have to write down one of them because they're going to keep alternating answers anyway. Alright? So some students are tempted to write it like this. They'd say pi 6 and the other one was 7 pi 6 plus 2 pi k plus 2 pi k. And this is like a silly answer because it's redundant. So all you have to say is pi 6 plus pi k. Okay. And then we still have the other one, and for the sake of time I'm just going to point out where it is. So here it's going to be this one, 5 pi 6, sorry. And again, this one's going to be an answer over here as well, 11 pi 6, and again it repeats every pi k. So we're going to say for the other one, x equals tan inverse of negative root 3 over 3, and so x equals 5 pi 6 plus pi k.